Mining and smelting ore is the first and most important thing that a factory needs to do, so today I'm going to be designing a set of modular smelter cells. These cells are going to be designed with transport belt capacity in mind to keep the layout planning process as quick and painless as possible, and they'll be configured in such a way that they can be easily upgraded as new technologies are unlocked. The first thing I want to do, though, is figure out how I'm going to set up the mining drills. A good way to do this is by placing small power poles at a distance of one tile less than their maximum span, and then run a belt underneath the poles so you can pack the drills in on either side. After setting up a quick blueprint that uses absolute coordinates, I'm deleting my rough design so I can rebuild it on the absolute grid, at which point I quickly realized I didn't follow my own advice and built the poles at their maximum span. After fixing my mistake and resetting the blueprint on a 7x6 grid, the drill cluster tiles nicely and I can move on to designing a drill adapter. The rest of my factory is on a 16x16 absolute grid, so I need an adapter which converts the 7x6 grid of the drills to the 16x16 grid of everything else. This can be achieved using a 7x8 header which aligns with the drill grid on one axis and the factory grid on the other axis. I considered putting the drills on an 8x8 grid to make the connection process easier, but as soon as I tried it I decided I wasn't happy with the gaps between the drills and reverted back to plan A. I figured since I was already using splitters to join the drill headers together, I may as well add lane balancers to them, and with that I decided I'm happy with the drill header design, so it's time to plan out the coal connection and start thinking about how the smelter cells will bring material in. For the smelter interface, I want to be able to bring in ore on one belt and fuel on another, and then use a pair of opposing splitters to distribute the ore and fuel onto a pair of inputs for the smelters. This gives me a general idea of how the material will flow into the cells, but before I can really do much with the interface, I need to know where the input belts are going to lie within the cell itself. According to my stopwatch, a stone furnace crafts 10 items every 32 seconds, which works out to 1/48 of a belt, so we'll need exactly 48 stone furnaces to consume one belt of material. Steel and electric furnaces work twice as fast, so we'll only need 24 of those to consume one belt. This means that if our smelter cells can be chained together to produce multiples of 24 furnaces, we'll always need a whole number of cells to consume a whole number of belts, which keeps the numbers nice and simple during the layout process. Since ore and fuel will be on the same belt, I can get away with burner inserters for the tier 1 smelter, and that way I don't have to worry so much about pole placement when only small electric poles are available. For the output belts, using a pair in the center of the cell will ensure there are plenty of gaps for the inserters to place material, plus it makes the cell more symmetric so I can sleep better at night. I want all my cells to be highly upgrade friendly, so now it's time to think about how this cell can be upgraded as we get deeper into the tech tree. Upgrading to steel furnaces doesn't require any major modifications, but electric furnaces pose more of a problem due to their larger footprint. I can only fit 8 of them in a quarter cell, but luckily if I need 24 to process a belt I can just use 3 cells connected in series. I have to move the input belt over a tile to make room, which means I need to swap to long arm inserters to make the smaller furnaces compatible with the wider belt configuration. From here I decided to start from the highest tier and work my way down, and hopefully meet myself somewhere in the middle with a design that works across all 3 tiers. After staring at the 3 mock-up layouts for half an hour, my palms were sweaty and steam was shooting out of my butt, so I decided to shift gears and started working on building a practical prototype. At this point I feel like I've made it about as far as I can without actually testing the thing, so once I get the power connected and the rest of the cell constructed, I'm going to move on to the interface so I can actually bring in some more and watch the cell in action. Now that I know where the input belts will be located inside the smelter cells, it's time to bring in some material and start building the interface. I already know that I need a pair of opposing splitters to prepare the input belts, so the first order of business is to route the inputs where they need to go. The first idea I have is to add a belt coming into the center splitters from either direction, so that it doesn't matter which side of the smelter the ore and fuel are coming in from to account for the variable positioning of resource patches. Delicious. It's always really satisfying to place the final piece, sit back and watch as a setup you've been planning for a long time finally becomes operational. After a quick tidy up to get things looking how they should, my next idea is to make a rough blueprint of the interface so I can do a check for rotational symmetry. It immediately bothered me that the inner splitters were slightly off, so I had the genius idea to add a second set of smelter inputs and contaminate the whole system with my lack of foresight. After cleaning up the mess I made on the belts and resetting the center splitters, I decided to try a different approach. By adding a splitter with a rightward output priority, material will first try to enter the smelter, and then it can overflow and continue downstream if there's a surplus. Using this arrangement, you can upgrade the ore belt so that banks of smelter cells can be placed in parallel and all draw from the same input. A second rotation check gives me an idea that's actually going to work this time. There's enough space to bring in another belt from the other direction, allowing the interface to receive material from both sides as well as overflow to both sides. A quick copy of the splitter mechanism to preserve rotational symmetry, and then I'm ready to make some adjustments to the electric poles. Now when I blueprint the interface and do a rotation check, the improvement to rotational symmetry is totally evident. These bidirectional inputs will also make it a breeze to switch the smelter over to a rail-based system when the resource patch starts running dry. Now that the smelter interface is up and running, it's time to finally take this thing for a spin. A quick modification that I'm going to try is to add a splitter on the center belts to help alleviate the pressure caused by all the inserters placing on the same lane. For the fuel-powered furnaces, this is kind of redundant because there are 2 input lanes and 2 output lanes, but having all 4 output lanes available is essential for the electric variant, plus the splitter will help keep things running smoothly if the system gets backed up. If the system works properly, it should take exactly 4 tier 1 cells to consume a belt of ore, so to test this thing properly I need to build 3 more cells. Luckily, the design as it currently stands is pretty easy to hand build if you follow the right order of operations and get your placement timing right, so it's pretty quick to get a fully functional smelter up and running. Things are a bit backed up at the moment because the furnaces were running while I was still building the output belts, but after clearing off all the excess material and letting everything stabilize, it all started working beautifully. Now that the tier 1 smelter has been tested, it's time to try out the upgrading process. My initial placement of the electric poles was intended to leave space for the bigger furnaces, but it didn't account for the fact that medium poles can't supply the outer inserters from their current position. Luckily, there is enough of a gap in the cell that I can just move the outer 2 electric furnaces over to make room for the poles, but when I applied the change to the tier 1 smelter I no longer had coverage of the interior long arm inserters. It was easy enough to fix by relocating the inserters, but unfortunately the new inserter spacing means the cell will be a little more tedious to place by hand. But that's more of a minor inconvenience than an actual problem. After blueprinting all the tiers, I was super satisfied with how the design was coming along and had a lot of fun cycling through them. After setting up an upgrade planner for the components, I moved on to testing the other smelter variants. The tier 2 variant is basically the same as tier 1, with the only difference being half as many cells are needed to process a belt, but with the tier 3 variant I started running into some problems with the output belts getting jammed. Placing splitters on the outputs worked really well at making sure they got filled, but I still wasn't quite getting 100% throughput on both belts. A clunky but viable solution I came up with was to replace half of the long arm inserters with regular inserters and then remove the output splitters from the blueprint entirely, but it made the process of upgrading from tier 2 to tier 3 even more tedious than it already was. This gave me a tricky design choice to make. Do I settle for almost but not quite optimal performance in exchange for ease of upgrading, or do I shoot for optimal performance at the cost of a clumsier upgrade process? In the end, I think the long-term gain of optimal performance outweighs the short-term cost of slower upgrading, especially since I should have construction robots by the time I need to upgrade the furnaces anyway. While I was working on the electric smelters, I had an idea for a more advanced version of the ore interface which allows it to feed 2 different smelters that head out in opposite directions to produce 2 isolated material feeds. This functionality won't be needed for all applications, so I'm going to save this as a separate blueprint, but I wanted to make sure the single output variant would be easy to upgrade to the dual output variant by ensuring the belts were all lined up in the right places. And with that final change, I think this design is just about ready to go. I'm sure there are some other modifications I'll want to make in the future, particularly when it comes to routing iron plates back into another smelter to make steel, but I'm saving that until I have a better idea of how transport belts are going to be routed around the factory. I'll address any additional problems that arise as they pop up, but for now I'm happy with how this design has turned out and I'm ready to move on to the next part of the factory. See you in the next one.